Okay, so the first question is, if 1 molar solution contains 0.5 mole of a solute, there is dash of solvent. How much amount of solvent will be present? Whether it is 500 ml, 500 gram, 100 ml and 1000 gram. If 1 molar solution contains 0.5 mole of a solute, what will be the amount of solvent will be having? Here they have given us molal solution. They have given us molal solution, right? So what will be the answer? Calculate fast and give me the answer. 1 molal solution they have given. So write the formula of molality and substitute these values in order to find the amount of solvent. Okay, so I'll wait for your answers now. Okay, have you calculated? So what is the formula of molality? Molality is equal to number of moles divided by. Molality means what? You must write the weight, right? So therefore, number of moles divided by mass of solvent. Okay, number of moles divided by mass of solvent. And molality is given as 1 molar solution. So 1 is equal to, number of moles is what? 0.5 divided by mass of solvent. So what will be mass of solvent here? And mass of solvent will be writing in kilogram, right? So mass of solvent will be equal to 0.5. 0.5 kilogram will be getting. Convert this into gram, you will be getting the answer. So what will be the correct answer? Yes, it is 500 gram of solvent. Okay, you will be getting the answer as 500 gram because it is 0.5 kilogram. Convert this into gram. So your answer will be 500 gram of solvent. If same thing, if they have given as a molar solution, same question. If it is for molar solution, then you will be calculate the volume, right? So therefore, volume of solvent will be equal to what? It will be equal to 500 ml. So ml for molar and gram for molal. Okay? Yes. And the next question is, which one of the following has maximum number of atoms? So calculate maximum number of atoms. Calculate the maximum number of atoms. What they have given? 1 gram of magnesium they have given, 1 gram of lithium, 1 gram of oxygen and 1 gram of silver. You have to calculate the number of atoms. Number of atoms. So calculate fast. What is the formula? We know that number of atoms is equal to number of moles into Avogadro number into atoms. You must multiply with atomicity. So similar problem we have already solved this type of problem, right? So number of atoms you need to calculate. So number of moles here, instead of moles they have given you grams. So they have given the mass. So we know the formula of moles is what? Mass by molar mass into Avogadro number into atomicity. That's it. Okay, so what will be the correct answer? Have you all calculated? Have you all done the calculation? Yes, see here, for the first one, 1 gram of magnesium they have given. So the mass is 1. And what is the molar mass of magnesium? It is 24. Avogadro number and atomicity, since it is 1 atom, so into 1. So 1 by 24 Na. So Na by 24. And next is for B, 1 gram of O2. So the mass is given as 1. So 1 by O2. What is the molar mass of O2? 32. Na into, here they have given you O2. So what is the atomicity? How many atoms are present here? 2 atoms. So into 2. So it will be 16, right? So Na by 16. And next is for the C, 1 gram of lithium. Again, here it will be 1 by lithium, mass is 7 into Avogadro number. Sorry, here it will be Na by 16 and here it will be Na by 7. And 1 gram of silver. Silver, it is 108, right? So 1 by 108 into Na. So Na by 108. So now tell me the maximum number of atoms. What is the maximum number of atoms here? You can relate these two. Number of atoms is inversely proportional to the molar mass. It is inversely proportional to the molar mass. So once if the molar mass decreases, the number of atoms will increase. So now tell me the correct answer. Which will be the correct answer now? For the second question. Yes, very good. It is option C, right? 1 gram of lithium is the correct answer. Yes, fine. So we'll move to the next question. So while you're answering, give the question number and the answer. Okay, only then I'll come to know you're answering for the which question, right? And the third question is the number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's processes. The number of moles of hydrogen molecule required to produce 20 moles of ammonia through Haber's processes. For this, first you must write the Haber's process equation, synthesis of ammonia equation, and you must calculate the number of moles of hydrogen you need to produce 20 moles of ammonia. Okay, so N2 plus 3H2 gives 2NH3. And also, you have to practice lots of problems. Only then you'll be able to approach the question, right? Only then you'll be able to know which concept you must apply for the particular question. Okay, so solve lots and lots of questions. Okay. Okay. So N2 plus 3H2 gives 2NH3. Now what you must concentrate on hydrogen molecules and ammonia, right? So you must concentrate on this. So for 3 moles, you'll be getting 2 moles of ammonia. And what they've asked to produce 20 moles of ammonia, what will be the number of moles of hydrogen? So X. So 3 by X is equal to 2 by 20. So what will be X? X will be equal to 3 into 20 by 2. So what will be X? X will be equal to 30. So you need 30 moles of hydrogen molecule to produce 20 moles of ammonia. Okay? Yes, very good. Option C is right. And next question is, which of the following is dependent on temperature? Whether molarity or mole fraction or weight percentage or molality. Which among these is dependent on temperature? Okay, so always remember the volume related will be affected by change in temperature. Volume related will be affected by change in temperature. So now you can answer this question. Which of the following is dependent on temperature? So the volume related one will get affected by the temperature. So it depends on temperature. So volume related depends on temperature. So which will be the correct answer? Whether it is molarity or mole fraction or weight percentage or molality. So which among these four have the volume term in it? It will be the correct answer. Okay, so what is the answer for fourth one? Okay, right. Recall the formula. You'll be getting this. Okay, the one which contains volume in it, it will be dependent on temperature. Okay, yes. So among these four, which formula contains volume? Very good. It is molarity, because we know that molarity formula is number of moles by volume of solution. Right? So here volume is present. So always remember volume related will be dependent on temperature. And the fifth question is 6.02 into 10 power 20 molecules of urea present in 100 ml of its solution. What will be the concentration of the solution? 6.02 into 10 power 20 molecules of urea is present in 100 ml of its solution. What will be the concentration of the solution? So what will be the concentration? We know that concentration is equal to number of moles by volume. Number of moles by volume. So here you need to find out the number of moles using the number of molecules. So what is the formula? Number of moles is equal to, if molecule is given, what is the formula? Number of molecules by Avogadro number, right? So what is number of molecules given here? 6.02 into 10 power 20 divided by, what is the Avogadro number? 6.023 into 10 power 23. Okay, so for simplification, I'm taking 6.02 into 10 power 23. So therefore, here what will be getting? We'll be getting 10 power minus 3 moles. Right? So we'll be getting 10 power minus 3 moles. Now, what they have asked the concentration. What is the formula? Number of moles is 10 power minus 3. By volume of solution, it is given as 100 ml. Convert this into liters, so into 1000. So your answer will be 10 power minus 2, which is 0.01 m. So option C is right. Option C is right. Okay. Next question is, what will be the orbital angular momentum of an electron in 2s orbital? So angular momentum, orbital angular momentum for a 2s orbital they've asked. What will be the orbital angular momentum for a 2s orbital? So you must know L value here. Okay, so for 2s orbital, what is the L value? What is the L value for sixth one? What is the answer? What will be L value? For s orbital, we have studied it is 0, right? So L value will be equal to 0. So therefore, angular momentum will be equal to what? 0. And next question is, which of the following magnetic quantum number is correct for the outermost electron in sodium? So where does this outermost electron present in sodium? First write the configuration. So it will be neon 3s1. So our outermost electron, it is present in 3s orbital. So what will be the magnetic quantum number for 3s orbital? Yes, L is 0. Very good. Okay. So what will be the answer for the magnetic quantum number for 3s orbital? Yes. So we know that S, if S is given, L value is 0. So M value is what? Minus L2 plus L, right? So M will be equal to 0 again. So option A is right again. And next question is, how many orbitals in total associated with the fourth energy level? How many orbitals are associated with fourth energy level? So how will you calculate the number of orbitals? Number of orbitals will be equal to n squared. Number of orbital is equal to n squared. Here it is fourth energy level. So 4 squared will be equal to what? 16. So number of orbitals will be equal to 16. If the energy level is 4, then you will be getting 16 orbitals. And last question is, the radius of hydrogen atom in ground state is 0.53 angstrom. What will be the radius of lithium 2 plus in the ground state? Okay, so already we have solved the similar type of question. Okay, so solve it. Solve this question. What they have given, the radius of hydrogen atom in its ground state they have given, right? So if it is ground state, then n will be equal to 1. So radius of hydrogen, it is given as 0.53 angstrom. What you must calculate? You must calculate the radius of lithium 2 plus. And if lithium 2 plus in the ground state they have given. So what will be n value for lithium 2 plus? Find out and apply it in the formula. We know that R is equal to n square by Z, right? And if you divide, you will be getting the answer. Okay, so what will be the correct answer? What is the correct answer now? Okay, write the question number and give me the answer. So what will be the correct answer? Here N is 1. What will be the N for lithium 2 plus? So we know that lithium, its atomic number is 3. So it will be 1s2, 2s1. So it will be 1s orbital, right? So N will be equal to what? 1. Because lithium 2 plus means you must remove 2 electrons. So here it will be 1s1. So in the ground state, what is the energy level here? N is equal to 1. Okay. So we know that RH2 is equal to what? N square by Z. So and RH2 value is given as 0.53 divided by R lithium plus we have to calculate. And what is N value? 1. Z value is 3. X. So therefore 0.53 by X is equal to 3. So what will be X value? So what will be X value? So it will be 3 by 0.53. So RH2 is 0.53 by X is equal to 1 into 3, right? So X will be equal to 0.53 by 3. So yeah, answer will be 0.17. Okay, so 0.176 angstrom. Okay. Yes, guys, so any doubt up to this? Any doubt? Okay, so once we'll recall what we have studied so far. Any doubts? Before that, any doubts? Are you clear with the concepts? Okay. So the first concept what we have studied is law of chemical combination. So we have studied what is law of conservation of mass, definite proportion, multiple proportion, Gay-Lussac's law, and the Avogadro's law, right? And we have studied the moles concept. It tells you that 1 mole of anything will be equal to what? 6.022 into 10 power 23. And if you want to calculate the number of moles, either you must know its mass or its volume or the number of particles. So if you know any one of these, you can apply these formula to get the number of moles. If you want to calculate the number of molecules, the formula is number of moles into Avogadro number. If you want to calculate the number of particles, that is, it can be electron, protons, neutrons, or atoms, you must include this number of particles present in one molecule. So if you want to calculate the number of atoms, you must multiply with its atomicity. Okay? Yes. And next is next concept is stoichiometry. In this, the very important concept is the limiting reagent. Okay, so you'll be getting numericals based on this limiting reagent. Okay, and next one is the measurement of concentration. So we have studied about molality, molarity, and normality. So molality will be number of moles by mass, molarity will be number of moles by volume, and normality will be number of gram equivalents by volume. And in structure of atom, we have brushed up the basic things like what is atomic number, what is mass number, and what is the number of neutrons, how to calculate it. And we have studied what is isotopes. Isotopes means you'll be having the same atomic number but different mass number. Isobars means you'll be having same mass number but different atomic number. In isotopes, everything will be different, but the number of neutrons will be same. And next comes the electromagnetic waves. And in this, you must remember this order. Okay, so in this order, wavelength decreases and the frequency will be increased. And we have talked about this Rutherford's gold foil experiment. Here we have studied 3 points. The first point is most of the alpha particles, they pass straight, and some of the particles will be deflected in large angles, and very few particles will be deflected back. And Next one is dual nature of matter. In this, you must remember these two equations. That is, for light, it will be Planck's quantum hypothesis, E is equal to h nu, and for mass energy relationship, E will be equal to mc squared. And Bohr's atomic model, here we have studied the electrons will be rotating in a circular path, and the electron will rotate in the path whose angular momentum must be equal to nh by 2 pi. And if the electron gains an electron, it moves to the excited state, and while coming down, it emits the energy in the form of light. And next, this Bohr's atomic model, we have studied the energy, radius, and the velocity calculation. And the most important thing is this radius calculation. Okay, so R is equal to n square by Z. And hydrogen spectrum, if n is equal to 1, that is, just now we have studied that if it goes to the excited state, it will come back to the state, ground state, right? To the lower excited one. So if n equal to 1, if it comes down to the first energy level, then this series is said to be a Lyman series. If n equal to 2, Balmer series. If n is equal to 3, Pascal. If n equal to 4, bracket. And if n is equal to 5, then it will be P-Friend series. And de Broglie's relationship, it tells that a wavelength and momentum, they are inversely proportional. So if momentum increases, the wavelength will decrease. Heisenberg's uncertainty principle tells that both the position and momentum cannot be calculated simultaneously for a particle. And quantum numbers, we have studied n, l, m, and n. Sorry, this is n. Okay, so if n is equal to 1 means what will be L value? It will be 0 to n minus 1. So L value will be 0. And what will be magnetic quantum number? Minus L to plus L. And spin quantum number is plus half and minus half. In addition to this, you must remember what does this magnetic, this quantum numbers it represents. N quantum number, it represents the energy level. L quantum number, it talks about the shape. And magnetic quantum number, it talks about the orientation. Spin quantum number, it talks about the orientation of the electron spin. And nodes is nothing but the probability of finding an electron should be equal to 0. Radial nodes will be n minus L minus 1. Angular nodes will be equal to L. And therefore, the total nodes will be equal to n minus 1. Okay. So if they ask you the radial nodes, you must apply this formula. If they ask you the total nodes, only then you must go for n minus 1 formula. Okay, don't get confused with this. And filling of orbitals, the important thing is this n plus L rule. And while applying this, if you get two values same, like the 6 and 6, then you must check the quantum, the principal quantum number. Okay, so the one which has higher quantum number, higher value, will be the one which is high in the energy too. Okay, so if you compare 4D and 5D, it is having the value as 6. N plus L value is 6. But which one will be in the higher state? 5. Okay, so check the N value in order to decide this condition. Okay, so that's it for today. Any doubts up to this? Any doubts? Any doubts up to this? Okay, so if you have any doubt, you can raise your hand. Any doubts? Okay, so don't forget to write today's test. Only if you practice lot and lots of questions, it will be helpful for you to attend in the exam, right? So in the exam, you need to attend about 35 questions for the Wheeler Institute, right? So you need to attend 35 questions in chemistry. So therefore, you must be able to approach the question properly first. So if you want to approach the question properly, you must be clear with the concept. Okay, so while seeing the question itself, you must know that I must apply n plus n rule here. Okay, if you know the concept better, you'll be having some time for the calculation. And if you're lagging in the concept, then you must be you must be taking long time in order to recall the concept, and also you'll be taking time for the calculation. So there will be no proper time management. Okay, so first be clear with the concept. If you're clear with the concept, then it will be easy for you to approach the question, and then you can use the time to calculate. Okay. Okay, so practice lot and lots of questions, and if you have any doubt, you can post it here in the doubt session. Okay. Yes. So any doubts up to this? Any doubts? Okay, Shivranjani. Okay, clear. Yes. Okay. And calculate, or you must practice more and more problems in the limiting reagent side. Okay. So do practice the problems in this concept, well, limiting reagent and stoichiometry. Okay, so number of moles calculation is somewhat easier. Okay, do lots and lots of practice in the stoichiometry and the limiting reagent concept. Okay, as for the some basic concepts, and in structure of atom, you go through the radius problems, energy problems, and also the quantum number problems. Okay, these type of problems you go through with. Okay, guys. So no doubts so far yet. Okay, fine. Okay, so tomorrow I'll meet you with the another concept. Okay, so tomorrow we'll be discussing this thermodynamics, I hope, gaseous state and thermodynamics. Okay, so we'll do it tomorrow. So by tomorrow, please be clear with the concept, practice lots and lots of questions after the session has over. Okay, do practice at least 10 to 20 questions per day. Yes, along with the practice test. Okay, yes, so take care, bye-bye.